Okay, so today is the day that I figure out how many mints I need to eat in order to get the maximum possible number of kisses I want to get when I get home. So here's my question. After repeated experiment, I found out there is a direct connection between the amount of mints I eat in a given evening and the amount of kisses I get from my wife when we get home. After compiling the data, the resulting graph, a function of mints, is below. Can you help me? How many mints should I eat in an evening to ensure that I get the maximum possible kisses when we get home? Why do you think the data forms a downward facing parabola? Okay, so there's a relation here. This forms this. Very interesting. So this is what we call a function of mints. We're saying that if we put in a number here, be it number 1, number 2, number 3, or whatever, then I get a result. I get a result of how many kisses I can get, for a certain number of mints. And how this works, let me just show you how it works. We say the function of mints, if we use a variable for m, is negative m to the power of 2, or negative m squared plus m. So what we do is we say the function now of 1. I want to know how many kisses do I get if I eat 1 mint. Okay, so the function of 1 is negative 1 squared plus 8. Okay, again we're replacing the m's with 1, right? So what is 1 squared? Well, that's 1. So that's negative 1 plus 8 times 1 is 8. So I get 7 kisses. So for 1 here, that's going to be 7. Let's see, that's maybe like over here. So for 1 mint, I'm going to get 7 kisses. So this point will be 1, 7. So how many will I get if I eat 2 mints? Well, that's minus 2 squared plus 8 times 2. Well, 2 squared is 4, so that's minus 4 plus 8. Well, sorry. Minus 4, 8 times 2 is 16. I was about to say that doesn't fit next time on the graph. Okay, well that's 12. We're making progress here. So if I eat 2 mints, I'll get like 12 kisses. So this is 2, here's 12. So this point is 2, 12. Okay, we're making progress here. I want to know what the maximum is. So a function of 3 mints minus 3 squared plus 8 times 3. Well, 3 squared is 9. So it's negative 9. 8 times 3 is 24. So it's negative 9 plus 24. So what's 24 minus 9? Well, 24 minus 10 is obviously 14. 24 minus 9, well, that's going to give me 15. Okay, so if I eat 3 mints, I'm going to get 15 kisses. Function of 4. So that's 4 squared minus 4 squared plus 8 times 4. Function of 4. 8 times 4. That's minus 16 plus 32. So that's 16 kisses. Okay, let's look at a function of 5. So that's minus 5 squared again. So do you see what we're doing? We're putting this number in the place of m at each given point. Plus 8 times 5. Okay, so that's negative 25 plus 40. Interesting, this becomes 15 again. Do you see? 40 minus 25. That's 15. Let's quickly see a function of 6. Function of 6, this is going to be 12. You'll see why now. Negative, okay, 6 squared plus 8 times 6. Okay, 6 squared, that's 36. Negative 36. 8 times 6 is 48. Okay, 48 minus 36. 8 minus 6, that's 2. 4 minus 3, well, that's 1. Can you believe it? Okay, so now we can see our graph here. So for 1 we said 7, for 2 we said it was 12, for 3 we said it was 15. So for 3 mints we said it was 15. So that'll be like around here, right? 3, 15. That'll be this point. 15's over here. Okay, and our maximum point for a total of 4 mints, I'm gonna get 16 kisses. So 4 on the x-axis gives me 16. But now if I eat 5 mints, function of 5, if I put 5 into this, if I get 5 mints, I get 15 kisses again. Let me line this up for you. 5 mints is also 15 kisses. And then we said that 6 mints is 12 kisses. Okay, so the data is quite clear. How many mints should I eat? Well, I should eat 4 mints. I should not eat more than 4. If I eat 4 mints, I will get 16 kisses. Now, why does it form a downward facing parabola? Well, this is where we just get fun, have a little bit fun with our interpretation. Maybe the mints bring a refreshing taste and to my mouth, so when my wife kisses me the first time, she feels that wonderful sensation of mints. But maybe if I eat 4, then it's really nice, it's this minty taste. But maybe at 5, the minty taste starts being a little bit sharp, so maybe if I had to eat 7 or 8 or 9, in fact, if this is 6, 7 is going to be around here, 8's going to have 0. If I eat too many mints, she won't even kiss me at all. So we can have fun with the interpretation, and there are actually many real-world things that work like this. And one example is plant fertilizer. I hope I spelled that right. Plant fertilizer. If you give a little bit, the plants grow a little bit higher. The more you give, the higher the plants grow. But you get to a point where you're going to get a maximum growth. And if you overfeed, the more you overfeed, the shorter the plants actually get. It's interesting. But you can build a function like this in Microsoft Excel and then use that with the given data you've received to determine the absolute maximum point. So this is very, very applicable using a quadratic formula like this. This is very, very applicable towards many branches of science. Now, for the grade 12s, I made a promise. My promise was that I would figure this one out using calculus. So let's do that. I'm gonna remove all this, and we're gonna use a derivative to find the maximum point, not just plotting all the points. It's actually another way we can use the turning point formula, where the x value of the turning point, or the maximum value, will be minus b on 2a. We're not going to do that one here. Let's do the calculus. Okay, so if f of m is negative m squared plus 8m. Okay, so if we take the derivative of this, if you're in grade 11, you won't know what this is yet, but if we take the derivative of this is going to be negative 2m plus 8. And as you might know, the derivative of a function shows you the gradient, how steep it is. There is a positive gradient, here is a very negative gradient, and over here you're actually going to get a 0 gradient. 0 gradient. So that's what we're looking for. We're looking to find the 0 gradient. So then what we do is we put our f prime of m, which is our derivative, we put that equal to 0. where in my graph am I going to have literally 0 as a gradient? So minus 2m plus 8 is 0, minus 2m equals minus 8 or negative 8, and then we just work that out. M equals 4. See, that's much easier and much quicker than what we did just now. Now this, what is this? This is the x value of the maximum or the minimum value, minimum point, and we can see that x4. And then what we can do is we can say again from here, how many kisses will I get? I've just determined how many mints I need to eat to get the maximum amount of kisses. If we were using calculus, then you would simply use the function of m, function of 4 again, which is negative 4 squared plus 8 times 4. So this is negative 16 plus 32, which will give me 16 times 2 is 32, so positive 16. So I must have 16 mints throughout the night. Not 16 mints, sorry, I must have 4 mints and I will get 16 kisses. Now I must say, you know, given my wonderful marriage, this is actually totally wrong. Really, it's totally wrong. I think the graph starts, if I had to really check what my marriage is really like, the graph starts about, I don't know, about here. If my wife who is watching this, she'll laugh, but this is true. Graph starts about here, and you know, I don't think the mints really affect things that much. So maybe the graph is more like this. No matter how many mints I eat, I still get a set amount of kisses. But it's a fun way. I think it's a fun little problem. So you can solve this using calculus, using the x value is minus b on 2a, or plotting all the points. But hopefully what this has helped you to understand is the applicability of a function in real life, and how it actually relates to real life, and also how we use this to find all the individual little points. So have a wonderful day. I hope you've enjoyed this.